On this 6.7 power stroke, P2002 may mean the particulate filter system is not trapping soot the way the PCM expects. The truck may show an emissions warning, may have reduced power, or may seem to regenerate more often. Broadly, the possible fault areas can include the diesel particulate filter, exhaust leaks or restriction changes, pressure sensing issues, base engine problems that contaminate or overload the filter, and operating conditions that interrupt regeneration. Start with the basic system checks. If other engine control codes are present, handle those first before chasing P2002. Also repair any base engine concern before making particulate filter repairs, because coolant leaks at the EGR cooler, leaking injectors, oil consumption, or excess fuel in the exhaust can damage the filter and set this code. If the PCM was reprogrammed or replaced before you got here, drive the vehicle for 8 kilometers, 5 miles, so the DPF PID data can update. Fuel quality matters too. This vehicle calls for 20% or less biodiesel. One monitor gate to keep in mind is 150 miles, 241 kilometers, after the first incomplete regeneration. And if regeneration starts during testing, let it finish before continuing, because the readings can be biased during regen. The RB path starts by sorting out whether P2002 is really the lead fault. If the scam results point into the particulate matter sensor side instead, do the visual checks in order. Look over the PM11 module, PM11 sensor, PM11 wiring and module grounds for heat damage, harness damage, wrong routing, wrong connections, and poor frame ground connections. Also check for exhaust leaks at flanges, gaskets, and the PM11 sensor, and consider radio frequency or electromagnetic interference. Next, look for contamination sources. Unapproved silicon sealers, excessive oil consumption, internal coolant leakage, or unapproved cleaning agents. If a contamination source is found, fix the source, change the oil and filter, clear the PCM codes, and retest. If that side stays clean, disconnect the PM11 module connector, turn the ignition on, and check C4861 pin 4. The voltage needs to be greater than 10.5 volts. Then, with the ignition off and the BJBC connector disconnected, check the VPWR and ground circuits for excessive resistance. The passing value is less than 5 ohms. For the PM11 module open circuit checks, the passing value is also less than 5 ohms. If the circuit checks pass, carry out a drive cycle. If codes return, unplug the PM11 module connectors, inspect for pushed out pins and corrosion, reconnect them fully, and see if the concern is still present. If it is, the shared path supports installing a new particulate matter Bank 1 Sensor 1 module. If it is gone, treat it like a loose or corroded connector issue. If no listed codes are present, the next check is for incomplete regeneration history. Watch the dist last regen PID. And if the dist last DPF value is between 100 kilometers, 62 miles, and 804 kilometers, 500 miles, the fault may not duplicate right away. In that case, check for loose connections, damaged or corroded terminals, and wiggle the harness to try to bring the concern back before clearing codes and retesting. If the pressure sensor side is the active branch, start at the DPF P11 sensor. With the ignition off, disconnect the sensor, inspect for pushed out pins and corrosion, then check the hose for leaks and the sensor port for restriction. Next, check VREF and SIG-RTN by measuring between C1471 pin 2 and C1471 pin 3 with the ignition on. The expected range is between 4.5 volts and 5.5 volts. If the branch keeps going into the DPF signal circuit, disconnect the PCM-T connector and check for a short to SIG-RTN or ground. The resistance should be greater than 10 k ohms. Then, check the signal circuit for an open between C1471 pin 1 and C1232T pin 81. The passing resistance is less than 5 ohms. After that, check for a short to VREF between C1471 pin 1 and C1471 pin 3. The resistance should be greater than 10,000 ohms. Finally, with the ignition on, check C1471 pin 1 for unwanted voltage. If any voltage is present, repair the short and retest. If no voltage is present, save the PCM connector operation check for the end of the path instead of guessing. For P2002, the path moves directly into checking for a damaged diesel particulate filter and exhaust system issues. With the ignition off, inspect the exhaust for aftermarket accessories, performance modifications, a damaged DPF, leaks, cracks, punctures, leaks in the DPFP11 sensor connecting hose, and tailpipe modifications that could change exhaust restriction. Then remove the EP sensor and the EGT11 sensor. Temporarily plug the exhaust pipe outlet and use a smoke machine or equivalent through the sensor fitting. Pressurize the exhaust system with 137.9 kPa, 20 psi, regulated shop air, and check for leaks and restrictions. Keep the air pressure controlled. Pressure above 241 kPa, 35 psi can damage system components. Reinstall the EGT11 or EP sensor when that check is complete. If that inspection or smoke test finds a concern, repair it, clear the PCM codes, and repeat the self-test. If no concern is found, the next move depends on which fault is leading the diagnosis. Some nearby branches first check for other self-test codes and move on to the next active code before continuing. Another branch checks the PTO circuit. Make sure the PTO switch is off, disconnect the PCM-T connector, turn the ignition on, and check C1232T pin 49 and C1232T pin 64 for voltage. If voltage is present, repair the short, clear the codes, and retest. A regeneration branch reconnects the DPFP11 sensor and carries out a diesel particulate filter manual regeneration with the scan tool. Do that only with the vehicle on the ground and the area around the tailpipe clear of people, obstructions, foreign material, and anything else that could be affected by the hot exhaust. The intermittent pressure sensor branch watches the DPF INP PID while you wiggle, shake, and bend small sections of harness from the DPFP toward the PCM. If that creates pressure spikes, repair the concern. If it does not, that branch supports installing a new diesel particulate filter pressure bank 1, sensor 1. Now for the target P2002 branch. If P2002 is not the only code present, stop treating it as the lead fault and diagnose the next active code first. If P2002 is the only code present after the exhaust checks pass, the path supports installing a new diesel particulate filter. After that, carry out the DPF parameter reset and clear the oxidation catalyst function, initialize SCR learning with the scan tool, clear the PCM codes, and repeat the self-test. If a manual regeneration does not complete, use the scan tool result to identify the concern that disabled it. Repair that concern, run the regeneration again, clear the codes, and retest. When the path is dealing with soot loading or repeated regeneration concerns, talk with the customer about how the truck is used. Excessive idle time, excessive low-speed operation, multiple short trips, and shutting the engine off during regeneration can all stack up and contribute to the fault. If those habits are present, advise the customer to follow the drive to clean exhaust message. Use fuel with no higher than 20% biodiesel content, run the manual regeneration with the scan tool, perform the DPF parameter reset and clear the oxidation catalyst function, initialize SCR learning, run the drive cycle, clear the PCM codes, and retest. Next, verify maintenance history and mileage. The diesel particulate filter should have been repaired or a new one installed at 193,000 kilometers or 120,000 miles. If the vehicle is over that mileage, the path supports installing a new diesel particulate filter and then performing the reset and learning functions with the scan tool. If mileage is not over that point, the remaining regeneration frequency path uses manual regeneration up to 3 times, then either installs a new diesel particulate filter if the concern remains, or returns the vehicle after clearing codes and retesting if the concern is gone. If that regeneration frequency concern is a repeat standalone issue, check the repair history, run the regeneration and reset functions, complete the drive cycle, clear the codes, and repeat the self-test. If the DPF signal circuit testing sends you to the PCM operation check, disconnect all PCM connectors, inspect for pushed-out pins and corrosion, then reconnect everything and make sure the connectors seat fully. If the concern is still present after that, the path supports installing a new powertrain control module. If the concern disappears, treat it as a connector seating or corrosion issue. There is also a pressure sensor rationality branch that starts with a PCM self-test and other PCM symptoms. If that branch is the only active PCM fault, inspect the DPF pressure sensors and hoses for restrictions, leaks, and damage. Repair what you find, clear the codes, and retest. If it is not the only fault, diagnose the PCM faults first. Finally, the related fuel vaporizer branch is a separate path, not the P2002 filter efficiency path. It starts by checking whether the fuel vaporizer faults are present, then visually inspects the downstream injector for damaged, cracked, or pinched lines and fuel leaks. For the downstream injector solenoid voltage check, disconnect it with the ignition off, turn the ignition on, and measure C1900 pin 1. The expected voltage is between 3.43 volts, 3.45 volts. Then check the circuits for an open between C1900 pin 1 and C123TT pin 62, and between C1900 pin 2 and C123TT pin 61. The passing resistance is less than 5 ohms. Check both C1900 pin 1 and C1900 pin 2 for a short to ground. The passing resistance is greater than 10,000 ohms. Then measure the downstream injector resistance between C1900 pin 1, component side, and C1900 pin 2, component side. The expected range is between 11.4 ohms to 12.6 ohms. If that fails, the path supports a new downstream injector solenoid. If it passes, reconnect the solenoid, remove the spray poppet from the exhaust pipe with the electrical connector still connected, install the injector test tool or equivalent, and run the downstream injection Baker test. The fluid volume should be between 90–110 milliliters, 3.04 to 3.72 ounces. If it is outside that range, that branch supports installing a new downstream injector assembly. Keep verifications separate from testing. Once the repair path is complete, clear the PCM codes, repeat the self-test, and confirm P2002 stays gone. The key on this one is not to condemn the filter until base engine concerns, exhaust leaks, hose leaks, restriction changes, and other active codes have been sorted out. For more diagnostic training, visit stepdiagnostics.com.